Imagine standing just a few hundred meters away from a skyscraper that took years to build. Suddenly, the countdown reaches 0. The ground begins to tremble, and within seconds the entire structure folds neatly into its own footprint. The roar echoes across the city, a cloud of dust races through the streets, and then, almost unbelievable, there is nothing left standing. But here's what nobody tells you. The real story isn't the collapse itself. The real engineering happens months before anyone hears that final countdown. You might think demolition simply means knocking buildings down, but controlled demolition represents one of the most carefully planned engineering operations in modern construction. Structural engineers spend months studying architectural drawings, surveying steel beams, reinforced concrete columns, and load paths that determine how a building carries its enormous weight. Every decision revolves around one goal: protecting nearby people, neighboring buildings, and critical infrastructure. What happens next surprised even experienced engineers when modern computer modeling transformed an industry once guided mostly by experience. Today we're stepping behind the safety barriers to discover how engineers inspect aging skyscrapers, bridges, stadiums, and industrial plants before they disappear from the skyline. You'll see advanced surveying technology, powerful demolition machinery, robotic equipment, environmental protection systems, and the incredible teamwork that makes these projects possible. By the end of this journey, you'll never look at a disappearing building the same way again. And this is where our story truly begins. Most people never think about what happens after a building reaches the end of its life. Before demolition begins, specialists identify valuable materials hidden inside the structure. Structural steel, copper wiring, aluminum, stainless steel, glass, and reinforced concrete each follow different recycling paths. Recovering these materials not only reduces waste but also saves enormous amounts of energy compared with producing new raw materials from mines and quarries. Steel recovered from demolished buildings often begins its second life in electric arc furnaces, where recycled metal replaces large amounts of newly mined iron ore. Copper removed from electrical systems can return to manufacturers after refining, while crushed concrete may become aggregate for roads and new construction projects. Imagine thousands of tons of material leaving one site only to become part of tomorrow's bridges, factories, and homes. A single demolition project can divert an astonishing amount of waste away from landfills through careful planning and recycling. Environmental teams also inspect every corner of older structures before demolition begins. They identify hazardous materials that require specialized handling under strict regulations, while air quality experts design dust control systems to protect surrounding neighborhoods. Water sprays, protective barriers, continuous monitoring equipment, and carefully planned waste management all work together to reduce environmental impact. And before a single wall comes down, another hidden layer of technology quietly takes control. The public usually notices only the dramatic finale, yet months of surveying, recycling preparation, environmental planning, and structural analysis happen long before demolition day. Every beam is mapped, every utility disconnected, and every safety zone carefully established. Only after countless inspections and approvals does the project move toward its final phase. In the next chapter, we'll step inside the remarkable world of demolition machinery and engineering technology that makes these complex projects possible. As the site officially enters the demolition phase, the atmosphere changes completely. The sound of engines replaces the silence of months of planning, while operators climb into machines that weigh as much as several fully loaded trucks. Imagine sitting inside a reinforced cab, surrounded by high-definition cameras, joysticks, and digital displays instead of simple levers. Every movement feels deliberate because one careless action could damage nearby structures or delay the entire project. The towering high-reach excavator becomes the star of the operation. Its enormous boom can extend more than 40 meters into the air, allowing specialized attachments to dismantle upper floors one section at a time. Hydraulic power delivers smooth, controlled movements while cameras and laser-guided positioning help operators judge distances with remarkable precision. From the ground, every motion looks slow, but each carefully planned cut removes tons of material in a controlled sequence. Below, another fleet of machines never stops moving. Wheel loaders clear broken concrete, tracked excavators separate twisted steel from rubble, and dump trucks shuttle recyclable material toward processing facilities. You hear the constant clank of metal, the deep rumble of diesel engines, and the crunch of concrete under heavy tracks. What looks like chaos from a distance actually follows a carefully coordinated workflow directed by supervisors across the site. Dust might seem like a minor problem, but it receives constant attention throughout the project. Powerful misting systems create a fine curtain of water that captures airborne particles before they drift into nearby neighborhoods. Environmental monitoring stations continuously measure air quality, while crews adjust suppression equipment as wind conditions change. Most people never notice these systems, yet they operate every minute to help protect workers and surrounding communities. Above the site, drones quietly capture every stage of progress. They generate detailed three-dimensional models that allow engineers to compare today's work with yesterday's surveys and identify areas that require additional attention. Artificial intelligence helps organize thousands of images into accurate digital maps, giving project managers an entirely new perspective on safety and efficiency. But even with all this technology, one element still proves impossible to replace: the experience of skilled demolition professionals making critical decisions in real time. By the time the last truck leaves the site, what once stood as a towering building has transformed into carefully sorted resources ready for a new life. Steel heads back to mills, concrete begins its journey toward new infrastructure, and the cleared land prepares for the next chapter of construction. It feels like the end of one story, yet it's really the beginning of another. And in the next section, you'll discover the astonishing technology and quality systems that keep modern demolition projects safe, accurate, and remarkably efficient. Imagine walking onto a demolition site where every machine, every worker, and every moving vehicle appears on a digital map in real time. Before the first wall comes down, engineers build a highly detailed digital twin of the structure using laser scanners, drones, and millions of measurement points. This virtual model allows the entire team to study the building from every angle without climbing dangerous areas. Most people never see this invisible layer of technology, yet it quietly guides nearly every decision on the project. Artificial intelligence now reviews thousands of images collected throughout the day, searching for tiny changes that the human eye could easily miss. It compares fresh scans with previous surveys, highlights unexpected movement, and helps engineers prioritize detailed inspections. Instead of replacing experts, these systems act like an extra set of eyes that never gets tired. The result is faster decision-making and a clearer understanding of how the project is progressing. Quality control extends far beyond the building itself. Surveyors continuously verify equipment positions, monitor nearby structures, and check that protective barriers remain exactly where they should be. Environmental specialists measure dust, vibration, and noise throughout the project, ensuring operations remain within regulatory limits. Every inspection adds another layer of confidence before work continues. For all the remarkable technology on site, there are still moments when human experience makes the difference. A veteran operator can recognize subtle changes in a structure's behavior, unusual sounds from heavy equipment, or signs that require the team to pause and reassess the plan. Years of practical knowledge combine with modern engineering tools to keep the project moving safely. Even the most advanced computer cannot replace judgment earned through decades in the field. As the final inspections conclude, the transformation becomes impossible to ignore. A site that once held aging concrete and steel now stands ready for renewal, supported by careful engineering, advanced technology, and thousands of hours of coordinated teamwork. Yet this story reaches far beyond a single project. In the next chapter, we'll uncover the surprising global scale of the demolition industry, the country's leading innovation, and the astonishing facts that reveal just how much our cities are constantly reinventing themselves. Every year, cities around the world remove aging buildings to make room for safer homes, cleaner industries, and more efficient infrastructure. The global demolition and construction recycling industry generates well over $100 billion annually, supporting hundreds of thousands of engineers, equipment operators, surveyors, environmental specialists, and recycling professionals. Countries including the United States, China, Japan, Germany, and the United Kingdom lead many aspects of modern demolition technology and material recovery. Imagine millions of tons of concrete and steel beginning a second life instead of ending up in landfills. Think about this. Concrete is the most widely used construction material on Earth, and demolition projects now recover enormous quantities for reuse as road base, foundations, and new building materials. Modern steel recycling saves vast amounts of energy compared with producing new steel from iron ore, helping reduce industrial emissions. Around the world, governments increasingly encourage a circular economy where yesterday's buildings become tomorrow's infrastructure. What once looked like waste has become one of the world's most valuable resources. Think about this. Concrete is the most widely used construction material on Earth, and demolition projects now recover enormous quantities for reuse as road base, foundations, and new building materials. Modern steel recycling saves vast amounts of energy compared with producing new steel from iron ore, helping reduce industrial emissions. Around the world, governments increasingly encourage a circular economy where yesterday's buildings become tomorrow's infrastructure. What once looked like waste has become one of the world's most valuable resources. Over the past 50 years, demolition has evolved from a largely mechanical trade into a data-driven engineering discipline. Artificial intelligence, robotics, autonomous surveying, electric heavy equipment, and advanced recycling technologies continue to reshape how cities replace aging structures while reducing environmental impact. As urban populations grow, engineers expect smarter planning, cleaner equipment, and higher recycling rates to define the next generation of redevelopment projects. The skyline may keep changing, but the commitment to safety, sustainability, and precision grows stronger every year. Today you've seen that removing a building is far more than simply bringing it down. It requires months of engineering analysis, environmental planning, advanced surveying, skilled operators, powerful machinery, and an extraordinary commitment to public safety. Behind every redevelopment project stands a team of professionals working together to transform the past into the foundation of the future. The next time you see an old building disappear from the skyline, remember, it didn't simply vanish. It completed one final chapter so new ideas, stronger structures, and more sustainable cities could take its place. Every recycled beam, every crushed piece of concrete, and every carefully planned operation helps write the next chapter of human engineering. If you want to go deeper into the hidden world of engineering and construction, tell us in the comments what project you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.